Okay, hello everybody. I apologize for the delay in the uploads. I was dealing with some issues with my recording stuff. I'm pretty new to making videos. And what was happening was I was using Zoom to record like a meeting and then use that to uh, write whatever I wanted on the whiteboard. And then what I realized was in the video there is a slight delay between me writing on the screen and it actually appearing on the screen. And I thought that's just kind of inconvenient to look at. So I've had to change my entire setup. I've had to change the app that I use to record the videos now. Hopefully this would be slightly better now. Um yeah. So today we're talking about solving questions using limits. Now, um, if you've forgotten what happened in the first video, I heavily encourage you guys to go and take a look at it again. We're just going to apply what we learned last time to these particular problems. So this first one is an example of a limit situation in which you have to simplify your fraction first. Now, first things first, always. When you're dealing with a limit, plug the value in. So you have -2, you should definitely try to plug that in. So if x is equal to -2, just equal to, you're going to plug it in. It becomes 5 over -2 minus 3 minus 1 over 2 times -2 plus 3. And all of that over 4 minus 4 at the bottom. So -2 squared, which is 4, and then minus 4. This leaves you with 5 over -5, which is -1, minus 1 over -4 plus 3, which is 1 over -1, which is on its own -1 over 0. And this leaves you with 0 over 0. So this is a indeterminate case, which means we would need to do some algebra on it somehow. We need to do something, right? It's not a good answer. It's one of those weird cases that I talked about last time. So what we're going to do here is we're going to do some algebra. So first, I'm going to try to simplify the top. The limit as x approaches -2. Now the top, how do I simplify that? Well, it is two fractions that are getting minus from each other, right? Now, how do we minus two fractions from each other? You have to have their common denominator. In cases where you're dealing with algebraic expressions, like this one, like the denominators are algebraic expressions, the surefire way of finding what the common denominator is just multiplying the two denominators together. So here, the denominator of the first one is going to be x minus 3 times 2x plus 3, same as the denominator of the other one. So it's going to be x minus 3 times 2x plus 3 as well. Now what's going to be on the top? Well, the bottom already had a x minus 3. Now you're multiplying a 2x plus 3 into it, right? So you also have to multiply that same thing into the top. This is going to be a very common theme in this course. Whatever you're multiplying into the bottom of a fraction, in order to conserve that fraction, in order to keep that fraction the same thing it was, you need to also multiply it into the top. Same for this one. It was 1 and then times uh, it had the 2x plus 3, so you have to multiply x minus 3 into it to conserve it. And all that over x squared minus 4. Now the good thing is, now that they both have the same denominator, you can just minus the tops from each other. It would be x minus 3 times 2x plus 3 as the denominator. And up top you'll have, I'll try to like open this at the same time just to not have to write a lot. So it would be 5 times 2x, I'm foiling this. So 5 times 2x, which is 10x. And then 5 times 3, which is 15. That's the first one. And then minus 1 times x minus 3, which is just x minus 3. Keep in mind that this minus is going to get applied to both things inside the bracket, not just the first. And this leaves you with the limit as x approaches -2. Now, you have a fraction up top, and then the whole thing is divided by something at the bottom. as a tip, I can tell you that if you have a fraction on the top of the whole fraction, the denominator of that top fraction can always just come down. So you can write this as x minus 3 times 2x plus 3 times x squared minus 4. If you're wondering why that is, that's just very simple. This is a division, right? So you're dividing that top fraction by x squared minus 4. Write it out, turn the division into a multiplication, and then flip the second one, and you'll see that you get the same thing. But if you don't want to go through all that work, just know that if you have a denominator on top of a fraction, like this one, this is a denominator on top of this whole fraction. It can just go down. And up top, you'll have 10x plus 15, and then minus x plus 3. So this leaves you with the limit as x approaches minus 2. And then you got 10x minus x, that's a 9x. And then you got a plus 18 over x minus 3 times 2x plus 3 times x squared minus 4. And hey, this is where it's going to happen. So we were supposed to factorize in a way that you have like an x plus 2 factor on both top and bottom, and then you can cancel the zeros out, quote unquote. Right? They're not exactly zeros because you're just approaching minus 2, right? But for our purposes, we treat them as zeros. So up top, I need a factor of x plus 2, which I can create very easily by factorizing a 9. They both have a 9 in them. So times x plus 2. Now the x minus 3 cannot give you a factor of x plus 2, neither can the 2x plus 3, but x squared minus 4 is going to give you a factor of x plus 2. How? If you remember to use a difference of squares. This is x squared minus 2 squared. So you can just do x minus 2 times x plus 2. For those who need a reminder, a squared minus b squared is just equal to a minus b times a plus b. Oops, I don't know if that actually worked. I'm gonna make that a little bit more to the left so you guys can see. So a squared minus b squared is a minus b times a plus b. That's the difference of squares. It's a formula that you guys should be very familiar with by grade 12. Now, I can just get rid of the x plus 2. Now that I got rid of my zeros both top and bottom, like if I plug a minus 2 in here, this is 0, so is this. I've basically gotten rid of what was creating this 0 over 0. Now I can very easily just plug in my number. So it would be 9 divided by minus 2 minus 3 times 2 times minus 2, which is minus 4 plus 3, and then minus 2 minus 2, which is minus 4. And this leaves you with 9 over minus 5, minus 1, minus 4, which will leave you with minus 9 over 20. This is one case. So it's the case of simplifying a very large expression and then trying to factorize. Now in the bottom one, you kind of have to do the opposite of that. So what we have is a root x minus 3 up top, but it looks like there's no correlation between what's up top and what's at the bottom. Well, there actually is a correlation. If you look closely, the bottom elements, so the root of x cubed and minus 27, are basically both cubics of the elements up top. So you have root x minus 3 up top, and then at the bottom you have root x to the power of 3 minus 27, which is 3 to the power of 3. Well, this is basically the minus of two cubic expressions. For that, we have the difference of cubes, which I will also write here. I probably need more space than that. Oops. Let's say a cubed minus b cubed. It turns out to be a minus b times a squared plus ab plus b squared. Now, in the same breath we talk about this one, we also have to talk about the sum of cubes, which is a plus b times a squared minus ab plus b squared. Both of these are extremely useful, especially in indeterminate form problems. Well, now what I can do is, according to this first one, I can just factorize the bottom of this. So it's the limit as x goes towards 9 of root x minus 3. And then at the bottom, you get square root of x minus 3, that's the a minus b, times a squared, which is square root of x squared, which is just x, plus a, which is root x, times 3, which is 3 root x, plus b squared, which is 9. Now, you see what happens is these two cancel each other out. Oh, I should have done this actually first. You should plug in 9 first, and you see that you get a 0 over 0. And this is how the zeros are canceling out. Don't make my mistakes. When you have a number, plug it in first, see that you get a 0 over 0 first, and then do all the hard work. Otherwise, a lot of your hard work might go to waste. And then from here, you get 1 over 9 plus 3 root 9, which is 3 times 3, which is 9, plus 9, which is 1 over 27. So in the cases where you have a 0 over 0, when you cancel out a 0 from top and bottom, that's your cue to go ahead and plug in your number. The second you canceled out the zeros from top and bottom, you're free to plug in. Now this bottom one is trickier. So this bottom one, if you actually plug in infinity in here, you don't actually end up getting 0 over 0. You end up getting infinity over negative infinity. So up top you get 6 times infinity squared, and that blows everything out of water. So that's just infinity. And at the bottom, if you plug in negative infinity, you also get negative infinity. So in reality, plugging in, which mathematically speaking is insane. You can't plug in infinity, it's not a number. But for our purposes, it works. You end up getting plus infinity over negative infinity, which is a indeterminate form, but it's not something that we can really deal with using the same methods that we dealt with the previous two parts. So what we're going to do is what I told you to do in those cases where you have infinity over negative infinity. You just factorize the highest power of x, both at the top and at the bottom. So you end up getting the limit as x goes towards negative infinity. So under the square root, what's the highest power of x? X squared. So it becomes x squared, all under the root, 6 minus 3 over x minus 2 over x squared. And then at the bottom, you'll have x times 3 plus 4 over x. So the first thing that you should notice is as x goes towards negative infinity or infinity in some other question, all these fractions of a numerical value divided by x become 0. Because if you have like 3 cookies and divide them by infinite people, the result is every person basically gets nothing. So this one is gone, this one is gone, this one is gone, right? The only tricky part here is bringing that x squared out. So you might be very tempted to just bring out x. Well, that would be incorrect. Why? Because if you bring out x, let's just bring out x and see how this goes. This becomes x times root 6, which is at the top, over 3x. Right? And this looks fine because the x's cancel out and you're left with a number. Well, the big problem that you have is look at the top. The top was a square root, right? The entire thing was a square root that we simplified into root 6x. Root 6x is a negative number because x is going towards negative infinity and root 6 is positive, negative times positive is negative. So what we're essentially saying is that the result of the root ended up being a negative number. And that's incorrect. You cannot have the answer to a root be a negative number. What's happening here is we brought the x squared out of the root and we just set it as x, whereas that's not correct. It turns out that square root of x squared is equal to negative x if x is less than 0, and positive x if x is or bigger than 0. Yeah. Oops. So in here, our x actually is negative, so we have to choose negative x. Keep in mind that this is the definition of absolute value of x. So it turns out that the square root of x squared is not really equal to x, but it's equal to the absolute value of x. So the only mistake I really made here is I brought x out, whereas I should have brought negative x out, because the square root of x squared, when x is negative x. It's not positive x. And now it works out. Your x's cancel each other out. You're left with negative square root of 6 over 3. Alright, so next time, just to not make this video extra long, we're going to be talking about continuity problems. And maybe a thinking problem as well, just so you see what kind of problems you're dealing with in the thinking section. Alright, see you guys next time.